Hello, everyone. All right. Today we're going to do something a little bit differently. We're going to try and get you to practice some equations. So we're going to use Pear Deck. So you can go to joinpd.com and type in that code, AQHGL, or City Quizzes Help Green Lemons. All right, I'm starting to get some students connected. Nice. And today we're going to be working on equations. So it's going to be a real revision lesson, I hope. I hope everybody kind of is really good with their equations. We're going to get into some problem solving. Okay, more and more students joining. It's good. One more minute and we're going to start. So obviously you can follow without joining this code, but I'm going to be able to quiz you as we go along and just see where everyone's understanding is at. I imagine this week we're going to be doing equations. So I imagine it's going to be a lot of revision for everybody. Hopefully everybody's, you probably learn equations right through to year 8, year 9. So we'll get into a few of the harder concepts with equations. But otherwise it should just be a bunch of revision for everyone. All right, let's get started. Okay, so we're going to actually, with equations, we're going to be going through it in a lot more detail than we did with algebra. So with algebra, we only spent 2 weeks on it. We had to get through everything in 2 weeks. But with equations, we're going to spend 4 weeks on it. And that's because we're not going to be just doing equations, solving equations. That's what we'll be doing this week. But we're going to be doing inequalities, and then we're going to be doing graphing as well. So, and simultaneous equations. So it's going to get harder as we go. This week, I think will be the easiest week. And I think it'll just be a case of just getting in the groove of things. So hopefully you'll go through it really quickly. So inside Mathspace, we split up equations into 9 subtopics for year 10. What we're going to be going through this week is the first 2. So it's really about solving linear equations, and we're going to get into some problem solving. And then over the next 4 weeks, we'll continue the rest of it. So next week, we'll be going through inequalities, so solving linear inequalities. And then after that, we're going to get into graphing and parallel and perpendicular lines and how to find equations of lines. And then the last week, we're going to go through simultaneous equations, which is one of the harder equations topics to go through. Okay, let me just open my chat as well to make sure I'm staying up to date with everyone. Remember to chat to all panelists and attendees if you want to chat to anyone. And also I'll open my Q&A. So just a reminder that with Q&A, I will save 10 minutes at the end to go through any questions. So feel free to enter your questions in the Q&A. All right. The other thing I'll mention is that we're going to go through this in a fair bit of detail. So hopefully we'll do a lot of the learning inside these lessons. But if you ever need any more kind of just walking through exactly how to solve equations, then jump onto wootube.mathspace.co and you'll get Eddie Woo's videos mapped to the Mathspace subtopics. All right, here we go. First one. These are warm-ups. I hope this is going to be really easy for everybody, and hopefully I'll be able to see all your answers as you put them through. So the very first warm-up question should be coming up on your screen now, and it's solve 4x is equal to x plus 15. Okay. Ah, cool. I can see the answers coming up on the screen. On my screen only. Okay. Is everyone able to enter their answers to that? Oh, and I can show responses. It's pretty cool. All right. We're getting some mixed answers. Well, getting a range of responses now. All right, there's some people that are a bit confused on how to do this. So what you should be seeing if you've joined the code, so you've gone to joinpd.com with this code, then you'll be able to see this on your thing, on your screen, and you'll be able to answer it, and I can see your responses. Okay, if you haven't been able to join, that's okay. You can just do it on pen and paper, and then I'm going to go through the answers over here as well. So this one's an easy one to start, hopefully, but I can see that there's a few different answers coming through. The most common answer was 5, x equals 5. So let's have a look at this. So the way to do this, of course, is, well, I think most people got x equals 5. So I'll go through it quickly, but we had an x equals 11, for example. So what to do is you need to isolate the x, so get the x on its own. That's the whole thing with solving equations. And the other golden rule of equations is whatever you do to one side, you must do to the other side so that they stay balanced. So if I have 2 equals 2, that's a balanced equation. Of course, 2 equals 2. If I add 1, make it 3. I need to add 1 to make it 3. So here, if we want to get the x by itself, we need to get rid of the x on this side. So we end up with just 3x there. So we'll subtract both sides by x. So that'll give us 3x is equal to 15. And the x minus x disappears. And then to get the x by itself, it's 3 times x equals 15. So we don't want 3 times x, we just want 1 times x. So it's x equals 5. I'm going to go through this quickly because I imagine that you know how to do this and I don't have to go through the exact steps of balancing the equation. Okay, and I can see most of you got that right. So, all right, well done to everyone. Got that right. Let's move on to the next one. These should be warm-ups. Okay. All right, you're seeing this one on your screen now? 7x minus 3 is equal to negative 6x plus 23. Watch the chat while you're working on this. Still a couple of people asking where they can join, so let me show that again. The way to join is to visit joinpd.com and use the code AQHGL. All right. So joinpd.com AQHGL if anybody wants to join, or acidic quizzes help green lemons. Okay, I can see most people have joined, and what are we getting for the answer here? All right, x equals 2, by far the most popular answer. So I'll just do this on Mathspace and confirm for anyone else going through this. So we want to get the x's by themselves. Now we could either move both x's, that x to this side, or we can move this negative 6x to that side. It's easier to move this so we're dealing with positive numbers. So to move it to the other side, we need to add 6x, get rid of it here and add 6x there. So that's going to give us 13x minus 3 is equal to 23. I'll just make this a bit bigger for everyone. And then now to get the x's by itself, we need to get rid of the minus 3. So let's add 3 to both sides. If I add 3 here, that'll disappear. If I add 3 there, I'm going to get 13x equals 26. And then that gives me x equals 2. All right, cool. Looks like just about everybody got that one right. So, all right, we're starting to get on the roll. All right, next one. Throw in some fractions. 5x minus 76 all over 8 is equal to negative 3x. Let's go. So you don't actually have to send the answer. As soon as you type something in the number, I can see it on my end. All right, starting to get some answers coming through. Okay, let me get into Mathspace. Okay, so first step, we need to try and get the x's all together, right? But very first thing when you're dealing with equations generally is to try and get rid of any fractions. We don't want to deal with fractions. They're hard to deal with, right? So to get rid of the fractions, we're dividing all of 5x minus 76 by 8. So let's multiply both sides by 8 to get rid of that fraction. So that's going to get rid of the fraction, give us 5x minus 76 is equal to 24x. Since we're multiplying the 3x by 8, we'll check that. Cool. Next step is to get the x's all on one side, right? So again, we could either move it to this side or move it to that side. It's easier to keep it positive. So if I subtract 5x from here, I'll get rid of the minus 5x, that 5x there, and I subtract 5x from here, I'm going to get 19x. Okay, so 19x is equal to negative 76. So I saw someone in the chat put 76 on 29, a couple of you. What mistake did you make there? Right, you actually added the 5x to the 24x. Oh, the presentation says the wrong question. My bad. Okay, so yeah, the presentation, it says negative 3x. I had that on the wrong slide. So now dividing both sides by 19. So you're actually, anybody who did put negative, who put 76 on 29 was correct. Now we just divide both sides by 19. And we have x equals negative 76 on 19. Okay, and that's 19 times, well, how are we going to do 76 divided by 19? Yeah, you can answer in the chat given the, so 76 on 19 is, well, is negative 4. All right, cool. Sorry about copying that question across wrong in the chat. Let's move on to the next one. Hopefully I got this one right in the chat. Well, yeah. Midway through when I was setting this up, I decided, hey, it's easier to take screenshots than to draw these things. So here we go. Hopefully that means I couldn't have got it wrong when I copied it over. All right, so last week we started looking at binomial expansions. Everything we learned in algebra is going to apply to equations. So let's see if everyone remembers their binomial expansions to solve this equation. All right, answers starting to come through. Oh, some of you are speedsters, actually. Yes. I don't know if you're right yet, but definitely fast. Remember your binomial expansions, and then remember in particular when you have a negative multiplied by a negative. It's probably the most common mistake that we'll get on this question. Okay, we've got a very popular answer, and we've got a couple of not so popular ones. All right, x equals 2 is the most popular. Let's see how we go. Yeah, looks like most people have got x equals 2. All right, so I'm going to expand. Minus 9x plus 18 plus 20x plus 25 is equal to 65. Okay, so most common mistake, like I said, is the -3 times the -6. So you make sure you make that the positive as you go through. All right, now I'll collect the x's together. Minus 9x plus 20x is going to give me 11x. Plus 18 plus 25 is plus 47. Love Mathspace will tell me if I'm right. No. 43. Thank you, Mathspace, for correcting me there. And then subtracting 43 from both sides gives us 11x equals 22. And there you have it. Your x equals 2. All right. Just about everyone got that one right too. All right, good. Good to see that you're still got your expansions going well. All right, here we go. It's probably the hardest thing now with equations is when you start introducing fractions. So this one's a relatively easy one. Solve n on 5 plus n on 6 is equal to 33. Let's go. Where the speedster's at. We got a speedster. N equals 90, maybe. If anyone's finished already, make sure, how would you go about checking your answer? So something I haven't talked about yet. All right. 90 seems to be the most common answer now. That's it. You substitute it back in. So if you go 90 divided by 5 and 90 divided by 6, add them together, you double check your answer. Okay. So there's a few different ways to do this. So let's see how everyone went about it. And I'll tell you my favorite way of doing it. So my favorite way of doing this, I mean, you could go with a common denominator and then working through that way. My favorite way is to go, okay, every fraction that's independent or every single term that we see here. So there's an n on 5, we have an n on 6, and we have a 33. And I look at the denominators and I say, what's the lowest common multiple? And then I'm just going to multiply everything by that. So we have a denominator of 5 and a denominator of 6. The lowest common multiple is 30. So I'm going to multiply everything here by 30. That's the way I would go about it. So it saves you the time of trying to write these with a common denominator. So, and you get to basically skip a step by doing this. So if I multiply that by 30, that by 30, that by 30, I haven't changed the equation because it's like putting 30 outside of, so let me grab my pen actually. Sketchpad. So it's like putting 30 back to draw outside of the whole thing. Right, and then I multiply the other side by 30. So you're not changing anything by doing that. So multiplying 30, so by n on 5 is going to give me 6n. The 30 divided by 5 gives me 6, and then plus 5n. And then that's going to equal to 33 times 30. Now, I'm going to just be clever and I'm going to avoid multiplying that. And I'll tell you why in a second. Just makes it a bit easier instead of dealing with 990. 6n plus 5n is 11n. And then instead of trying to work with the really high numbers there, I just know that if I divide 11 by both sides, then 33 divided by 11 is 3. So I just get n equals 3 times 90. 3 times 30. And then that's my n equals 90. So I guess there's maybe the person who got it super fast. You know, if you've got these little mental tricks like that, you can just start to work with small numbers as you go through. All right, but very impressive. Everyone seems to be getting all of these right. Okay, so using that kind of technique now, let's see how quick you can answer this one. We've got early answers starting to come through. We've got some disagreements on the answers too. So using the technique that I just discussed, we've got basically 3 terms there. And 2 of them are fractions, and the lowest common multiple of those 5 and 4 would be 20. All right, we've got some disagreements happening. All right, let's work through it. Oh, we've got at least 3 answers coming through here. So here's the first one where we haven't really had a unanimous response. All right, let's start. So like I said, I'm going to multiply everything by 20. So I'm multiplying really the whole thing here by 20, which means I multiply that by 20 and that by 20. And of course, don't forget the negative. So why did I choose 20? Because the lowest common multiple. So 20 divided by 5 gives me 4. So what I end up multiplying is 4 outside of. Very important, you're multiplying the whole numerator. So I'm going to do it slowly and put it all in brackets rather than do it in one step. And then minus, and we're multiplying this by 20. So 20 divided by 4 is going to give me 5. So 5 outside of 3x minus 6. I'm seeing some people change their answer, which is good. So maybe some people forgot the minus or forgot to multiply the whole thing through. And then 3 times 20 is 60. All right. So that's where I would start. And that way I've gotten rid of all the fractions in one go. And now I've got one of the ones we practiced earlier. We just need to use binomial expansions. So to expand this one, we're going to get 20x minus 16. And then expanding this one, again, don't forget, so we get negative 5 times 3x and then the negative times the negative. So we're going to have minus 15x. And then minus 5 times minus 6 is going to give us plus 30. All right, now combine terms. So the 20x minus the 15x is going to give us 5x. Minus 16 plus 30 is plus 14. And so we have 5x is equal to 60 minus 14, 46. X equals 46 on 5. Cool. All right. Hopefully everyone followed that. Yeah, we got, most people got the right answer, but significant people were a little bit off. All right, cool. Looks like everyone followed, right? So there's so many places you can make a mistake here. So it's really important that you're systematic with how you go about it. So like I said, my favorite way, there's other ways to do this. You could have made 20 the common denominator, but once you've worked out that's the common denominator, you can kind of skip a step if you just multiply every term by 20. So you should get rid of the fraction by doing that, because the 20 on the 5 gives you the 4. don't forget to multiply the whole numerator. So use brackets. And then of course the negative times the negative is the other big one that's going to catch people out. Okay. Okay, I'm just going to pause and just see if there's any questions. So it doesn't look like there's any open questions. If anyone has any questions on the chat, doesn't look like it. All right, and we're going to move on to part 2 then, which is problem solving. Okay, I'm going to start with a bit of a worked example, just to introduce a bit of the graphing concept with equations. So I'll work you through this, and then we're just going to do a couple of harder maths problems, problem solving questions. Okay, so I guess this problem solving is when you really start to see where mathematics comes to life, how you're going to actually solve problems. You in the real world will solve many equations as you just get through, whether it's in your job or in just in living life. You have to be able to kind of find the unknown number. So here's an example of one. Consider the points in the table. The time is measured in minutes. By how much is the temperature increasing each minute? So really important just to take your time to kind of understand what's going on here. We have time 1, 2, 3, 4, 5, and the temperature starts at 5 and it's going up consistently by 4. Okay. All right, so what would the temperature have been at time 0? Feel free to throw the answer in the chat. Okay, I'm seeing somebody say 1, and that's just following the same pattern going backwards. Cool, so the answer is just 1. If you can imagine, if we put a 0, that would be over here just before the 1, and so it'd have to obviously be going backwards by 4. All right, here we go. Now, let's find the algebraic relationship between x and y. Okay, who can write an equation that links x and y? Okay, we've got an x equals y plus 1. Not quite. Y equals 4x plus 1. What do we think of that one? All right, a couple of people coming in with y equals 4x plus 1. Yeah. So remember when it was 0, it was 1. And that's really helpful to see what it is when it was 0. Okay, we had a 0 there, we had a 1 there. And that kind of tells you what the plus 1 is, because this is when 4 times 0. So that's how you know it's kind of going to be a plus 1. And then the going up by 4s is the clue to have the 4x. Okay, so it is actually y equals 4x plus 1. If I multiply the x here 2 by 4, I'm going to get 8, and then add 1 gives me the 9. So what's a good way to work it out? Seeing how much it goes up by, that probably tells you what's going to be in front of the x. And then seeing what it is when x is 0 tells you what the plus is going to be at the end. So y equals 4x plus 1. All right, now, so let's have a look at graphing this. So on Mathspace, the way to go about graphing this is we said when x was 0, y is 1. And then it was going up by 4. So when x was 1, y was 5. And then we can check some other points. When x equals 2, we have y is equal to 9, exactly as we expect. So you can graph that. Any other point should be on that line. Okay, cool. So that gives you a kind of idea of the graphing side. Now we're going to get into graphing in a lot more detail in the coming weeks. But just wanted to kind of give you an idea of how you can use graphs and equations and kind of start to see what they look like on a graph. If you haven't done this yet, don't worry, we're going to go into it in a bit more detail next week. Okay. Now I want to move on to some problem solving questions, worded problems. And I'm going to give you a couple of minutes actually to do this. To manufacture desks, the manufacturer has a fixed cost of $34,100 plus a variable cost of $180 per desk. Okay, so we just had a kind of a look at what, if you can think about that in a graph term, if you wanted to, the fixed cost when it was 0. Okay, so over here on that axis, always every month, it's going to cost $180 per desk. Oh, sorry, it's going to cost $34,100. But then the additional costs depend on the number of desks, $180 per desk. So what we need to do is find N, the number of desks that need to be produced so that the average cost per desk is $290. All right. Just hold off on putting your answers in the chat and just give everyone, I need everyone 3 minutes. 2 minutes, 2 minutes. See how you go. All right, starting to get a few answers coming in. All right, let's go through it. Okay, so let's think about first what the total cost is going to be, right? So there's a fixed cost of $34,100. That's going to be happening every single month. And then there's a variable cost of $180 per desk. Okay, most of you got 310. Let me show you the responses actually. Okay, somebody got 118. So 34,100 is the fixed cost. That's going to happen. And then the cost, the additional cost just depends on the number of desks. So if there's N desks being produced, it's going to cost 180 times N. Okay, so that's the total cost. Now we need to find the average cost. So the average cost per desk, to work out the average cost, we're going to have to divide the total cost by the number of desks we had. So we got to divide the whole thing that we've got here by the number of desks, N. So that's what we're trying to solve. And we know the average cost is 290. And this is the hardest part of problem solving with equations. The hardest part is getting the first equation right. After that, it's just the same as any other equation. We're just solving an equation. So hopefully if everyone got that part, that's the hardest part. From there, we do the same things that we've always been doing for solving equations. So I'll just take a little bit more time to explain this again. So total cost, fixed cost, plus for every desk, 180. So 180 times n. And then the average cost, we're going to divide the total cost by the number of desks. Okay, and then from there, we just multiply both sides by n to get rid of the fraction. Subtract 180n from both sides. So it's equal to 110n. And then we can jump on our calculator and work that out. N equals 310. All right, really good. Nice. All right, I'm going to give you a harder one. Let's do this. Neville can paint the average house in 10 hours, while Eileen can do it in 15 hours. Find the number of hours T that it would take to paint a house if they both worked together. This is a challenge. Somebody already coming through some answers. Whenever you come, once you come up with your answer on this one, just check, do a bit of mental, logical checking in your head if it makes sense. Right, this is fun. Okay, I've got one answer that's 18. So, okay, we've got a 12.5 coming through. We have an 18. Okay, well, I want the person who came up with 18 to think about it logically. Don't even think about the equations yet, like a reasonableness check. If we have Neville, great painter Neville, he can paint a whole house in 10 hours. All right, really good painter. Eileen, solid painter, but a bit slower, takes 15 hours. They decide, you know what, we need to finish this thing super fast, let's work together. If they work together, they kind of got to paint less of the house each, right? So definitely, it's going to take a shorter amount of time, right? If Neville can paint the whole house on his own in 10 hours, then if he has Eileen's help, definitely going to be shorter. All right, so there's just a reasonableness check to be like, oh, am I on the right track here, or am I like way off? Okay, so we got some people saying 6 now. So the 12.5, that's the one, that's the most common mistake, to just go, it's got to be halfway, because they're working like One takes 10, one takes 15. Let's go halfway. But they're working together now. It's actually going to be shorter. Answer definitely has to be less than 10. Exactly. All right. Answer must be less than 10. All right, let's do another like reasonableness check, right? I'm going to pick two numbers that I know the answer has to be in between those two numbers. So I'm going to go with, let's imagine, so Neville's the better painter or the faster painter, right? So let's imagine Neville, we had two Nevilles. If we had two Nevilles, it would be a really easy question, right? So just tell me in the chat, if you had two Nevilles painting this house, how long is it going to take? I'm looking for answers in the chat. All right, coming through, so easy, right? 5, right? 10 hours, I get 2 of me, I can do it in 5. Great. If we had 2 Eileens, a bit slower. If we had 2 Eileens, how long is it going to take up 2 Eileens to do it? 7.5. All right. Eileen does it in 15, so we have 2 of her, 7.5. Okay, you have a really great reasonableness check right there. My answer, once I've done my equations, if it's not between 5 and 7.5, then I'm wrong. Oh, Rishika, that's you see that one come through. Okay, so somebody said 6.25. Let's just go halfway in the middle. That's an interesting way of looking at it, but incorrect, because Neville will be able to paint still faster than Eileen. So it won't quite be in the middle of the 5 hours and the 7.5 hours. Rashid has an interesting approach, okay, without using equations. Just gone, hey, if we went with, if they had 30 hours, how many houses would they paint? That's really clever. If you had 30 hours, then Neville will paint 3 houses and Eileen will paint 2 houses. So just looking at the lowest common multiple of 10, 15 is 30. So altogether, in 30 hours, they'll paint 5 houses. So on average, it'll take 6 hours to paint a house. That's a very, very clever approach. And you didn't even have to use equations, but pretty cool, pretty cool. That's the correct answer. The correct answer is 6, but let me show you how you could do it with equations, right? So let's jump into this demo. So the way I'm going to think about it is, how much of the house will they paint in 1 hour? Okay, so who can tell me in 1 hour, how much of a house can Neville paint? I'm looking at the chat. All right, in 1 hour, you can do 1/10 of a house. So Neville in 1 hour gets 1/10 of a house. How much of a house can Eileen paint in 1 hour? All right, everyone's ahead of me, okay? 1 on 15. So Eileen goes 1 on 15. We need to find the number of hours that it would take to paint a house. So if I multiply this whole thing, I get this, multiply that whole thing by T, how much of a house can they paint in T hours? All right, you see what I've done there? Gone, if in 1 hour they can paint 1/10 of a house and 1/15 of a house, then in T hours, they can paint T times that amount. And we know that it took them T hours to paint a house. So in T hours, they paint 1 house. And that's how I got that formula. Yeah. So it's really clear what this left-hand side represents. So we're talking about the number of houses painted. We need the left-hand side to be equal to the right-hand side. The number of houses painted in T hours is 1. So that's why the 1 over here. This is an expression for the number of houses painted in T hours. In 1 hour, 1/10 plus 1/15. So in T hours, T times that. Okay, and then somebody did put something really similar in the chat before, but that's like, to everybody, that should make really logical sense of what each side represents here. And then the way to do it from here, you can multiply the T out both ways. So I'll write this as T on 10 plus T on 15 is equal to 1. And then it's just one of our solving equations with fractions, right? We look for the lowest common multiple and multiply everything by the lowest common multiple. So in this case, 30 goes into 10, or 10 goes into 30, and 15 goes into 30. So 30 divided by 10 is 3, so 3t. 30 divided by 15 is 2, so 2t, and is equal to 30 times 1, 30. And we have 5t equals 30, and then t equals 6. All right, so well done. And it's interesting because a couple of you got that right, did it in a completely different way. I love that approach that didn't even use equations. Very clever, just went, okay, imagine they were painting 30 houses. How long would it take? And then working out that'll take 5 hours to do that. Or 5 houses. Sorry, in 30 hours, imagine they had 30 hours. How many houses would they paint? 5. And then just going, okay, so on average, it's 1 house every 6 hours. All right, very nice. So a couple of lessons here that I really want you to take away. One is just take the time to really understand the question and give yourself a bit of a reasonableness check, right? So if we just spend a bit of time just thinking about the question, we'd know straight away our answer had to be between 5 and 7.5. And then the other takeaway is to kind of think about what are 2 things I can make equal. So in my case, my approach was to say the 2 things I can make equal is the number of houses painted after t hours. So we know that it equals 1. And then it was like, okay, how do I find an expression for the number of houses painted in t hours? Once I make them equal, then from there, just solve the equation. Okay, I think that's all I had for today. So I'm going to put a challenge question up for anybody that wants to have a go at this. It's going to use a bit more of the algebra that we went through last week. And if anybody else has any questions that they'd like to throw in the Q&A, then feel free to do that. Otherwise, we'll go through this last question and we'll catch you all next week. So the challenge question: a right-angled triangle has a hypotenuse of 15 centimeters. I'm sure you've all seen right-angled triangles and Pythagoras theorem in the past. So I don't have to tell you about that. Hopefully it rings a bell. If the other side is 3 centimeters longer than the shorter side, find the length of all sides of the triangle. So we're calling the shorter side X. We know something else about this triangle, that the other side is 3 centimeters longer than the shorter side and the hypotenuse is 15. So we've got a problem. We can use it to come up with an equation. Yeah, using Pythagoras, and please using equations. I think if you know the answer just by trial and error or something like that, then that's all well and good, but I want you to use equations. What equation can we write? And then let's go through and solve it. I'm going to have to use our skills that we talked about last week with expansion and factorization. So it's a bit of a challenge question. Yeah, there we go. Okay, so somebody I can see has got just knows their Pythagorean triads really well. So 3, 4, 5, just multiply everything by 3, get 9, 12, 15. Okay, so that's correct. And you've got the right answer. Now, how can you prove it by equations? I saw another answer there that was really close, that with an equation. Just remember that X is the shortest side. So the length of the other side is going to be X. Is it X plus 3 or X minus 3? So we know, let me bring up my annotation tool. Okay, so if the shorter side was x, then this side here is going to be x plus 3. And so what we're looking to solve, so again, with equations, what we need to do is just say, what are two things that we know are equal? Let's make them equal. Well, we know that a squared plus b squared equals c squared. So we have our equation. So we have our x squared plus, and now it's all of x plus 3 squared is equal to the 15 squared, which is 225. Okay, now we're going to use everything we learned last week. Expanding, so that's x squared, and then you remember perfect squares, so it's x squared plus, and then we multiply these two together and then multiply by 2. So hopefully everyone remembers that from last week. And then plus 9, the 3 squared, is equal to 225. Got ourselves our equation there. And we simplify that a bit more. We get 2x squared plus 6x plus 9 is equal to 225. Now this is where it gets a little bit tricky. We need to move everything to one side of the equation and make it equal to 0. And I spoke a little bit about this last week. So you'll be able to follow even if you haven't learned quadratic equations yet. If you have learned quadratic equations, you should know this. So let me, where should I write this? I'm just going to go up this way. Okay, so that's going to give us 2x squared plus 6x. And then plus 9 minus 225 is minus 216. Is equal to 0. And then I'm going to just divide everything by, or I'm going to factorize out the 2, or divide both sides by 2 is probably even easier. So I get x squared plus 3x minus 108 equals 0. That is 108. Okay, and then who remembers last week what we need to do? Who remembers how to factorize? Yeah, that's it, factorize. So we need to find two numbers that multiply to give negative 108, not 108, multiply to give negative 108 and add to 3. So this is where your multiplication comes in handy. Okay, and so it's going to be 12 and 9 gives 108. And which one's going to be negative? So to work out which one's, we need them to add to 3, so we want the higher number to be positive. So it's x plus 12, x minus 9. Can I undo? So we got x plus 12, x minus 9 equals 0. And this is the part that you'll learn in quadratic equations, but if we have two numbers that multiply to give 0, that means we need one of those two numbers has to be 0. So we can either have x equals minus 12, which would make that 0, or x equals plus 9, and we can't take the negative measurement. All right, it's coming in the chat, so we have x equals 9. All right, cool. So the answer is x equals 9, and then all those who are really good at their Pythagorean triads would have recognized straight away that 9, 12, 15 is a perfect Pythagorean triad, because it's just the 3, 4, 5 multiplying everything by 3. So really cool. All right, that's it for today. I have one question I'll go through. So somebody's asked, are there some general rules for linear equations similar to BEDMAS or PEMDAS or BODMAS, whatever you, people call that? There is. So just generally when you're working on equations, you have to make sure you undo the last thing that you did. So let me clear all drawings, close this. Okay, just go to an empty page so I can annotate. So I'll just give you like a really quick example of what I mean by that. Okay, so if I have 2x plus 5 is equal to 11, right? Somebody asked about the order of operations, like bed mass, bod mass, whatever you use for that. Why? Actually, the same rules apply when you're solving equations. So a really good way of seeing this is, if I start with the number x, what did I do first? Did I first add the 5, or did I first multiply by the 2? And so we know we first got to x and multiplied by the 2 because that's the order of operations. You do the multiplication first, and then you add the 5. So whenever you're working with equations and kind of going backwards, you always are doing it in the reverse order. So first I multiplied by 2 and added the 5. So what I need to do next is go, okay, I'm going to unwind the adding the 5. So you actually, the rules of mathematics flow right through to equations when you're solving it. So the BEDMAS rules go straight through, and we subtract the 5 before we divide by 2. If you divide it by 2 first, you're kind of just going to mess the whole thing up. So you subtract the 5 first, which is why you get the 2x equals 6. And you kind of work from there. So hopefully that answers your question. All right, so that's it for today. That's the only question I saw. So thank you, everyone. We'll catch up next week. Next week, you're actually going to have a new teacher that's going to join me. I might join as well, but you're going to have Jono joining, who's a really good teacher, who's going to be taking the next class. I'll be away for a couple of weeks. I'll see if I have time to just pop in and say hello, but thank you so much for joining, and keep studying, and hopefully we'll catch you all next week. Bye, everyone.